The first you will learn about the isotopes, and then we will move to its application. What is the role of the isotopes to calculate the atomic mass? So here isotopes mean having same protons. Same protons mean having the same atomic number. So let's suppose these are the examples are given over here. Now you can easily calculate the number of protons, neutrons, and the electrons as we have already discussed before. So these are the element, and the element name is the hydrogen. So look at the three symbol over here, and in these three symbols the representation is with the capital H, that is for the hydrogen. So as I have already talked to you, whenever this is the atomic number, and when it is the one atomic number, it must be the hydrogen, and whenever it is the hydrogen, it must have the one atomic number. So if you move to the other one, so if it is 1 2, that means this is the atomic number, it is less than, and this is the less than 2, this is the mass number. And when you move to the third one, again this is the atomic number, this is the mass number. So mass number may be vary, and but the atomic number will remain the same in case of the isotopes. So these are the isotopes to each other, and why we call them the isotopes, because having the same protons. So this is the atomic number 1, atomic number 1, atomic number 1, that means proton 1, 1 proton is here. So these three elements are having the same protons, that's why these are called the isotopes to each other. And this is also very easy to remember. Iso means same, topes mean protons. So it is ending with the sound P. P mean the protons, and iso mean the same protons. So isotopes mean having same protons. If you find the different elements having the same protons, these are called the isotopes. So now the question over here, how can you calculate one of the information I have already shared with you? This is the atomic number. You can easily calculate the number of the protons, and you can also calculate with the rest of the information over here. One protons mean one electron is there, and the number of neutrons, mass number minus atomic number. So there are no neutrons in case of this hydrogen 1 and 1. There is only one proton and there is only one electron. Atomic number is 1, mass number is 1, but there are no neutrons. So here in case of the other 1 2, this element symbol is called the deuterium. This is the protium, deuterium, and this is the tritium, representing with the 2, that is the deuterium, represented with the 3, that is the tritium. So you can also calculate the number of neutrons. 2 minus 1, the number of neutrons are 1, and there are 3 minus 1, there are the 2 neutrons. So you can also say the same protons but different number of the neutrons and different number of the mass number. These are called the isotopes to each other. Whenever there are the same protons, there must always be the different number of the mass number or different number of the neutrons. So if one is same, the rest will be the different. So there are only 3 subatomic particles we are discussing: number of protons, neutrons, and the electrons. So this is all about the what are the isotopes. So here I am going to show you the application of the isotopes, isotope and the average atomic mass. Let's suppose this is again it is the another element, carbon 612. So Reba, could you stop marking? So this is the okay. So this is another element, carbon, and there are the 2 isotopes are given. This is carbon 612 and carbon 630, and the first is how can you identify these are the isotopes to each other? Again, these are the same element, carbon, having six atomic number. That means it is also having the six proton. This is also having a six protons. So the protons are different. Oh, sorry, protons are the same. So that's why these are called the isotope to each other. So this is the one information you are getting, how to identify the isotopes. Now we are going to apply this knowledge to calculate the average atomic mass. So naturally, now look at the this value. Uh, we are not actually using the exact 12, but here 12.011 is given. So now the question is how it is coming out from the atomic mass, why it is the 12.011, not it is the 12.00, so on. So like in a similar way, it is given over here, atomic number is 6. So this may be the 12, but it is 12.011. So now to answer this one, there is a role of the isotopes. So generally in the periodic table, the elements are having the average atomic mass. Average atomic mass means the sum of the masses of the all the isotopes of the respective element. So I am going to calculate how to calculate this 12.011. So naturally there are the two isotopes, carbon 612 having the percent abundance of 98.89%. That is the natural abundance available naturally. And this carbon 613 is having only 1.11%. So if it is only having the 100%, then of course it would be the atomic mass would be the 12. But sum of the mass is this, and sum of the mass of carbon is 613 is 1.11. So now how can you calculate? This is the very simple formula is given. The mass of the carbon 612, or you can say any of the isotope. So because I am using this example, this is having the two isotopes. So this is the mass of carbon 612 multiply by the percent abundance of the carbon 612, that is 98.89%, plus now this is the mass of the carbon 613 multiplied by the percent abundance of the carbon 613. Similarly, if there is another isotope, you can add up the isotope, like in case of the hydrogen, as we have discussed before. There are the three isotopes, so you can calculate the average atomic mass by using this. The mass of this isotope multiplied by the percent abundance of this plus mass of this percent abundance of this plus mass of this percent abundance of this. So it doesn't matter there are the two isotope or more than two isotope. You can calculate by using the same formula. Again, there are only one multiplication and one summation. There is no complicated calculation over here. So this carbon 612, one carbon is having the mass of 12 and percent abundance is 98.89. This is the percent. To convert into the number, you have to divide by 100. So this is, you must remember this one, because whenever you calculate the percentage, you multiply by the 100. So to convert into the whole number, you have to divide by the 100. So when you divide this figure by 100, it would be 0.9889. So this will be the calculation after division of the 100. Now plus you can put the mass of the carbon 613. 613 mass is having 13.00434 and multiply by its percent abundance, that is 1.11, and again you have to divide the this figure with the 100. This will become 0.00111. So this is the you are getting from the percentage. So all these mass and the percent abundance will be given to you. Again, you do not worry about how you will get all these information. All information will be given, but only the way to calculate, how to calculate, this is actually the objective of the class or the content. I am going to teach you how you can calculate the atomic mass of any of the element by using the their percent abundance and the mass of the carbon. So when you solve this one, you multiply this one plus multiply this one, this will be this, and finally you will get the answer 12.011. So see, this is the mass of the carbon 612. This is the 12.011. So that is the reason why it is not the whole number. This is the 12.011 because this is the sum of the masses of all the isotopes of the carbon. That's why it is in the fraction. So again, just remember this formula. I am going to do the exercise over here by using the same way I am giving you the value, and you must remember how to calculate the this atomic mass by using this very simple formula. So again, you must have to multiply the mass of the concerned respective isotope with the percent abundance, and then you have to sum up all the masses and the percent abundance. Finally, you will get the answer. So this is the exercise. Again, I have asked you, I have explained to you, all information will be given to you. This is the nitrogen, and this is the mass number of the nitrogen 14. Remember, nitrogen is having the atomic number is this, atomic number 7, and the mass number is 14 point something, and this is the atomic number is not given because to calculate the average atomic mass, you only need all this information, and this is the percent abundance. So please do your calculation and let me know what would be the answer. So let me show you what is the answer of this. It may be after 14.007. If you have put another values over here, that is correct. So this is the way 14.003074 multiplied by, you have to divide by 100. So this will be the 0.9963 plus again this value multiply by, you have to divide by 100. This will be the 0.0037, and when you sum up, that will be 14.007, and so on. You have correctly done this one. So by using, I'm just giving you two of the examples you can do at home, because there is again the due to the shortage of time. This is the example 3, and the element is chlorine. Chlorine having the two isotope 35 mass number and 37 mass number. Again, we are not concerned about the atomic number. Whenever it is a chlorine, atomic number must be the same as given in the periodic table. Their masses are given over here. Percent abundance is also given over here, and this is the silicon. Silicon is having the three isotopes. Again, don't be worried, you can add up the third isotope in a similar way. Mass, the exact masses are given, percent abundance are given. So I am going to show you the answer. So you must calculate yourself, and then you can match your answer with the results. So the first answer for the chlorine is 35.453, and the fourth one exercise, silicon is having the mass of 28.086. So these are the answers of all these two exercises. So please do yourself, especially the students who have not done right now. So don't be just to prepare for the examination. Just do this very simple calculation. So you will learn some basic mathematics to convert the one unit to another unit, or to do some very simple calculation over here.